Okay, so in this question we have to show all our workings, and we need to make sure that we're not just relying on our calculators, because we're not going to get full marks if we do that. So to start with, for part A, we've been given a figure. We've been told that the curve C with this equation here, so this is my quadratic, is going to be my curve C, and we know that the line is the equation y equals 2. So we've got the line y equals 2 here. And to start with, we want to write down the coordinates of D. So let's start there. So for D, we've got x equals 0, and x equals 0, y equals 5, if we're looking at the equation of our curve. So that means that our point D is equal to the point 0, 5. So we found the equation for the point D. So part B, the curve is intersecting the line at the points E and F. So we want to find out what's happening when y equals 2. So when y equals 2, x squared minus 4x plus 5 is equal to 2. X squared minus 4x plus 3 equals 0. So we need to solve this quadratic, but we need to make sure we show our working. So I'm going to factorize it to be x minus 3. X minus 1 is equal to 0. And we know that E comes before F on the graph, so that's going to give me the point where E has got the x coordinate of 1. And we know that the y coordinate for both of these is 2. And at F, we've got the coordinate of 3, 2. And actually what the question's just asking me is for the x coordinates. So I'm just looking at E, I've got x equal to 1. And at F, I've got x equal to 3. But having the actual coordinates might help me later on in the question. So part C, we have got shown in the diagram the region R1 is bounded by C and L and the y-axis. So we can see this region R1 that's here. And the region R2 is bounded by C and the line segments EF and DF. So this is my line segment EF, and this is my line segment DF, and I can see that segment there. And it's told me that the area of R1 divided by the area of R2 is equal to K, where we've got some constant. So we need to use algebraic integration. And again, this is your indicator that we can't just use the calculators here. So let's look. R1 is going to be the area under the curve here. So we know that R1 is the integral between 0 and 1 of my curve, which is x squared minus 4x plus 5 minus 2, and I'm integrating that with respect to x. So we get x cubed over 3 minus 2x squared plus 5x minus 2x. I could have obviously combined those two into 1 a little bit sooner. That would have been a bit tidier, between 1 and 0. Obviously, all of these terms are going to be 0 when x equals 0. So I'm just going to substitute in the upper limit, which is going to give me 1/3 minus 2 plus 5 minus 2, which is equal to 4/3. So we know that my area for R1 is 4/3. So let's now look at what the area of R1 plus R2 is. So if we think about what R1 plus R2, what we've got there is just a triangle. So my R1 plus R2 is a triangle that looks like this. And we know that it crosses the axes here at 5. We know that this point here is 2. And we know that this point over, so this height is going to be 3. And we know that the difference between these 2 points here is from 0 up until where F was, which was at 3. So R1 plus R2 is going to be a triangle, which is a half times by 3 times by 3, which is 9/2. So that gives me R1 plus R2. So that allows me to find out what R2 is. So that means the area of R2 is equal to 9/2 minus 4/3, which is 19/6. So we know what the area of R2 is. So let's think about what the question's asking then. It says that K is equal to the area of R1, which is 4/3, divided by the area of R2, which is 19/6. and that gives me 8 over 19.